In this demonstration, we will be looking at how statistical distributions can be used to add variation to your simulation models. Statistical distributions can be used for process and setup times. They can be variant dependent or independent. And we can add variation also through something known as effective process time. For this demonstration, we are going to use a very simple serial production line. We have 3 variants, part A, B, and C. They are produced in a cyclic manner in the source, like this. 5 part A, 5 part B, and 5 part C, and then it starts over again. Still missing is the processing times, and we will go through that in this demonstration. Let's start by setting up our model with constant process times and setup times. Select all operations. Input 60 seconds as processing time and 60 seconds as setup time. For process time, that will be used for all variants, in this case part A, B, and C. And the setup time will be 60 seconds no matter going from part A to part B or C, or whichever switches occur in the model. If we run an experiment, we can see that our throughput is 50 parts per hour and we have 0 standard deviation. Every out of the 5 replications is exactly 50. No variation. Looking at the utilization, we can see that all machines are working exactly the same amount, 83%, and the rest of the time they are being set up. Okay, let's add some variation to our model. Select all operations. Open the process time editor, and instead of using this constant value, we go for a normal distribution. The mean value being 60 seconds and the standard deviation being 10 seconds. The lower and upper bound can be used if you want to limit the allowed values for this processing time, but we stick with the unbounded version. And similarly for the setup time, we switch from the constant value to something like, can use the exponential distribution here, and we can stick with 60 seconds. Now we run an experiment again, and our throughput is decreased. Remember, it was 50 without any variation in the model, so the variation degrades the performance of our production line. And you can see the values from each replication here. Utilization wise, we have now gone down to around 80% working, and we have some blocked waiting and also blocked and waiting. We can right click and sort on order in model, which makes more sense. So the first operation we can see is blocked, the second one is waiting some and is blocked some, and the last one is waiting and working. Up until now we have used variant independent process and setup times. Now we're going to go through how to add variant dependent process time and setup times. Select all operations. Once again, open the process time editor, and at the top you select table. You see the variants present in the model listed here. Select all and add them. And you can add a time or a distribution for each variant here. So let's go for a normal distribution. Let's put this as 50 seconds. This one to normal and 1 minute, and the last one to normal and 70 seconds. Okay. Similarly, for the setup time, you select table at the top, and we add these 3 variants. And for setup time, when we add variant dependent setup times, it means going from part A to part A, this takes 0 time. Going from part A to processing part B will take exponential. We can put 50 seconds there. And from part A to part C, we put exponential 70 seconds. From part B, from part C to part A, finally the last one. Okay. And we run an experiment. And now we're down to 46.9 pops per hour. And the variation went up slightly. And you can see that the working portion went down a little bit by adding this variation. This is variation between variants as well as statistical variation due to the distributions. Okay, this far we have added variation through statistical distributions, both for variant dependent and variant independent case. Now we're going to see how you can model variation in human execution, and that is done through something that is known as effective process time. Let us first go to the help file. We search for EPT, and this is what we get. It stands for effective process time. In the model, we start by randomly picking a value according to the input we have. It might be a constant time, or it might be from a distribution, or from a table like setup times or variant dependent processing times, etc. So we picked 703, that's our randomly picked processing time, and around that value we create the distribution that mimics the behavior of human variation or machine variation or failures or whatever that makes the time vary. And we randomly pick a value within that distribution. So our resulting processing time in this case could be 715. Okay. So if we apply this effective process time to our processing as well as our setup, the only option is to have it off, then it's none, and manual effective process time, that is used to model variation in human performance. So if we run an experiment with this, we look at the throughput, it went down slightly compared, so we added some additional variation to our model by doing this and lost productivity because of that. You can also see that the working portion went down slightly. To summarize, we've looked at using constant times for processing and setup time, and we looked at how we could use statistical distributions as well as variant dependent processing times and setup times. And lastly, we saw that we could add variation due to manual execution by enabling the effective process time option. Thanks for watching.